Chapter 4 deals with solving systems of linear equations. In Section 4.1, we're going to be focusing exclusively on systems of two equations, two unknowns, but in later sections we will look at larger systems, particularly three equations, three unknowns. Also in Section 4.1, we're going to be using the technique of elimination to solve these systems, although later on we're going to be learning how to solve them using matrices, which there are certain advantages to doing it that way, but we'll discuss that later. So in this problem, I need to solve the system 2x plus y equals 5 minus 4x plus 6y equals 12. So when I say that we need to solve this, what I mean is we need to find a pair of numbers, x and y, that satisfy both of these equations simultaneously. So to solve this problem using elimination, what I need to do is I need to choose one of the equations and multiply it by a constant so that when I add the result to the other equation, I get one of the variables canceling out. So that'll make more sense when you see it in action. So what I'm going to do in this particular case is I'm going to choose the first equation and I'm going to multiply it by 2. You'll understand you'll understand soon why I'm choosing to multiply the first equation by 2. But if I do so, I'm going to end up with 4x plus 2y equals 10. I just multiply all of the values, everything in that first equation by 2. The second equation stays the same. It's still minus 4x plus 6y equals 12. Now the reason why I chose to multiply the first equation by 2 is right here. I ended up with 4x in the first equation, but minus 4x in the second equation. So now when I add these two equations together, these 4x's are going to cancel out. And I'm going to be left with an equation only involving y. So that equation is going to be, I have a 2y and a 6y, so that's 8y, equals 10 plus 12 is 22. Then I divide both sides by 8, and I believe that gives me y equals 2.72. 2 3/4. So this gives me the y value in my solution, but I still need to find the x value. So to do that, I just need to take the y value I found and plug it into either one of my original two equations. And it doesn't matter which equation I use. However, it looks like the first one is going to be a little bit simpler, so I'll plug into that. So my first equation was 2x plus y equals 5. And if I plug y equals 2.75 into this equation, I get 2x plus 2.75 equals 5. Then I subtract 2.75 from both sides, which leaves me with 2x equals 2.25. And then dividing both sides by 2, I get that x is equal to 1.125, or in other words, 1 1/8. Okay? So I'm going to summarize my solution by putting both values in the solution together, x and y. So x is 1.125 and y is 2.75. So that is the solution to the system. Okay, we can actually plug that back into the equation to double check and make sure that we have a correct answer, but I'll show you how to do that with the next example. Okay, so in part B, the system we're solving is 2x plus 3y equals 1, and x minus y equals 3. Okay, so I want to cancel out one of the variables. Let's say I wanted to cancel out x. Then I would multiply both sides of this equation by minus 2. Both sides of the second equation by minus 2. That would end up with me having a minus 2x in the second equation, and then when I added that with the first equation, the x's would cancel. Now let's say I wanted to cancel out the y's instead. We actually have a little bit of a choice here. If I wanted to cancel out the y's, I would multiply the second equation by 3. And then that would end up with me having a minus 3y in the second equation, which would cancel out with the positive 3y in the first equation. I'm actually going to do it this way. Either way is fine. The only reason I'm choosing to do it this way is because in this scenario I'm multiplying by a positive number as opposed to the negative 2 I had earlier. And so it's probably less likely that I'm going to make a sign error if I do it in this way. So, carrying out this operation, the first equation stays the same. It's still 2x plus 3y equals 1. The second equation is 3x minus 3y equals 9. So as I was mentioning before, when I add these together, the y's are going to drop out, and I'm going to end up with 2x plus 3x is 5x equals 10. And so then dividing both sides by 5, I'm simply going to have x equals 2. So that's the x coordinate, or the x value in my solution. So now I need to solve for y, and I can plug into either of the previous two equations I want, but looking at them, it looks like the second one's a little bit simpler, so I'm going to plug into that one. X minus y equals 3. And then my x I found was 2. So I have 2 minus y equals 3. I subtract 2 from both sides to get minus y equals 1. And then I multiply both sides by negative 1, or divide both sides by negative 1, however you want to think about it, and I get that y is minus 1. So summarizing my solution, I get x equals 2 and y equals minus 1. Okay, like I mentioned in the previous part, we can actually check these to see if we have the right answer. So let's see how that works. Our initial equations were, what were they? 2x plus 3y equals 1 and x minus y equals 3. So this x and y we found should satisfy those. So let's check. Plugging into the first equation, we have 2x, so that's 2 times 2, plus 3y, so that's plus 3 times minus 1. So that's going to give me 4 minus 3, which is 1. That checks out. So let's double check the second equation. I get x, which is 2, minus y, which is negative 1. 2 plus negative 1 is 2 plus 1, which gives me 3. That also checks out. So it looks like we do, in fact, have the correct answer.